Hello student, in this video we will look at summarizing data that are quantitative. That is, it's all about number. From the list you see here, we have histogram, frequency polygon, ogive, stem and leaf plot, dot plot, and line graph. Again, the list is not comprehensive. You see here the example of each, and then some more here. We will look at the example of two of these. For all these ways we use to organize quantitative data, I encourage you to look at how each is done in the textbook to familiarize yourself with these. Practice some from the text to help you understand how they are constructed. Let's do the example in your lecture notes here. So you have a list of numbers. The data, raw data. First, let's try to organize it in a stem and leaf plot. For the stem, we need to determine the first of the numbers. Since this is 2 digits, you look at the first of the number for stem. If it is 3 digits, you will look at the first 2 numbers as stem, and so on. So, for this data, it seems that we have 5, 6, 7, 8, 9 as stem. So begin with drawing a line straight down. Then write 5, 6, 7, 8, 9 on the left of the line. Next, we begin tracking and writing the second digit in its order. So begin with the 50, we see that we have 56 and 59. Since 6 is smaller than 9, we write 6 first. Then write 9. Next is the 60. We have 64, 65, and 69. So we write the second digit in that order, 4, 5, 9. And so on. Let me take a moment to write down the rest of the number. Notice that if there is a repeat or multiple repeat, you must write the second digit for each of the repeat. So here's what we got for this data as the stem and leaf plot for 8 and 9. Why do we need this? This is a visual way for us to quickly determine the distribution of the data. Remember what the distribution is? It also helps us determine any possible outlier. Or other important information. It looks like we have this data is skewed. You will learn what it means for data to be skewed in a later lesson. The next example we're going to do is the dot plot. For a dot plot, draw the horizontal line. And make the mark, since we already know that the number goes from 50 all the way to 99, which is about 100. So what you're going to do is start with 50. And evenly make the mark for the rest of the 10. Okay. And go ahead and plot a dot for each of the number. So as you can see here, I got 56, which is a little bit in the middle between 50 and 60. Then we have 65 and so on. So let me go ahead and plot the dot that I have pre-made. Each of the dots represents each of the data. Okay, so you see the data is pretty small in sample size, and you can see that each of that represents each of the data, so you really can't see the distribution that much in the situation. For the dot plot to work, it would be best if you see a lot of repeats and the sample size is large. That way you can see the distribution. Here you can still see the distribution, but it's rather quite insignificant. It still seems to be skewed. Okay, the last thing we would like to take a look at in this video is the ability to accurately interpret graphs that provide you with statistical information. If you look at the first two examples here, you would say that each tells you information about different things, but it's not. It tells you information about the exact one thing. Passenger traffic at Denver International Airport. Passenger traffic at Denver International Airport. Please pause the video for a moment, take a look at those first two graphs, and see what you interpret from the graph. Then press play again, and we will talk about it. Okay, so you see here in the first graph, on the left, this graph here. You probably think that this graph shows small differences in the number of passengers at Denver Airport between any 2 years, because the bars seem like pretty much the same height. So it's really not telling you anything when comparing between the years. On the graph to the right, which is this one right here, you see that the year 2006 generates very small number of passengers as compared to the year 2012, with significant difference in number of passengers. So you start. Look again at the number. See 47, 48, 49, 50, 51, and for the graph on the left, 0, 5, 10, 15. Okay? The number gives you the clue to the true information. Although the largest difference according to the second graph is between 2006 and 2012, you see the difference here is 6 million between the 2 years. And we are talking about number in tens of millions for the second graph. Yet the visual of the second graph makes it look like there is a huge difference. The first graph shows a sure to the real fact, showing that the differences between any 2 years are small. So you can see here, if I draw the line across this for the 2006 and the line across this for 2012, you can see that the difference is small. So how do you avoid the pitfall? The graph should start at 0, just as this one right here. Should start at 0. Not any other value, because 0 gives you a precise picture of where it begins and compares, number-wise. Why? Because you are used to the number system, and the number sense in your mind is based on the number system. Secondly, when looking at the visual graph, look for numbers that make your mind think numbers as you observe the visual of the graph. Visual, for the most part, are for show. See it here for yourself in the last graph that contained the airplanes. This is the worst of the bad, since it gives you no number to determine the value depicted in this particular study. In this case, your statistical sense tells you to disregard the presentation of the graph entirely. You can see for the rest of the other graphs, they are similar to the first two graphs we discussed. Just remember to make sure that at least the vertical axis start at 0. like this one to help you picture the value in comparison. And last but not least, look for a number that you can compare. In the next video, we'll look at another way we organize data, particularly the data that we collect to variable or bivariate data. See you next time.